Hello, this short video is part of the Hypothesis Tests 1 lecture in the QED module. And in this we're going to look at the first part of this section, how a simple t-test works. Now this section deals with all the technical backgrounds behind these examples we might have looked at above here. So we'll begin by looking at how you can find p-values or probabilities, because as you'll see, all tests deal with probabilities. So you can find p-values or probabilities from tests in two ways. One is what's called Monte Carlo simulation, finding frequencies, how often different things happen. The other way is by using theory. For example, if you want to find what's the probability of throwing 2 on a die, one way, the Monte Carlo way, is by throwing one die many times and counting how many times you get a 2. Another way is by theory, saying, well, there's 1, 2, and there are 6 possible scores, so it must be 1 in 6. In Excel, you can do a simulation or a Monte Carlo process by pressing F9. That makes things recalculate, and using the RAND function. But t-tests are entirely based on theory. Having said that, t-tests can then be validated by using something like Excel to test that your theory works. But you don't need to do that because they do rely entirely on theory, as we'll see. So these are the ingredients or the ideas that you need to understand how a t-test works. You need to understand about the normal distribution and z-scores, as we started looking at in the previous lecture. And you need to know what happens when you sample. And by sampling, I mean when you go to an area, you don't talk to absolutely everybody. On the other hand, you don't just talk to one person. You need to know something about probability, because all the results are in terms of probability. And there's one more distribution, slightly different from the normal distribution, called the t-distribution, and that's why it's called a t-test. So in this short video, we look at the first two. We begin to look at the first two. So z-scores, to recap, it turns out that it's really useful when you're dealing with a normal distribution to know how many standard deviations you are above and below the mean for any given value. And that's called the z-score. So if you've got a number you're thinking of, x, and you want to know what's the z-score for x, that's this number here. You subtract mu, the population mean, that tells you how far above or below you are from the population mean, and then divide by standard deviation, which tells you how far above or below you are in steps of standard deviation. And we had lots of examples of that during the last lecture, in the last lecture workshop, in terms of examples, and also on the problem sheet. Hopefully you've worked some more. And there'll be more in future problem sheets as well. Now, what we do next is we move beyond z-scores to what's called sampling. So the z-score is telling you about an individual. If you pick one tree, one person, one country, and how far above or below the mean is that. And it also deals with the assumption that you have populations which are normal. Now, unfortunately, z-scores are not so good for non-normal populations, and the more non-normal they are, the more hopeless z-scores are. And even more unfortunately, all of the most interesting variables tend to turn out to be non-normal. Things like income, land, livestock, trade patterns, all this sort of thing. Often really non-normal, skewed distribution, heavily positively skewed, often sometimes negatively skewed. In those cases, the z-score for individuals is pretty hopeless. So, partly as a response to that, we usually sample more than one individual. So what effect does this have? If you're doing a survey or you're doing some research somewhere, you don't generally go and talk to one person, or measure one tree, or catch one fish and measure that. You catch a whole bunch of fish and talk to a whole bunch of people. What effect does it have when you sample more than one individual? Now at this point, we need to turn to a demonstration online. So this link here takes you to it, but if you're watching this video, you'll need to go to Blackboard and find the sampling distribution link, and then you can follow the sampling distribution, which I'll describe in the next video.